Good morning, everyone. My name is Richard. I am the lead data platform engineer at Runna, and I'm here to talk to you today about how we are supercharging our data with the power of Snowflake. So a little bit of a background about me. I have been working in data for over 10 years at this point. The majority of that I've also spent working in the AWS cloud platform. And I first started using Snowflake in around 2021. I've got a background mostly in kind of startups, although I've done a decent amount of consultancy as well on a few different kind of public sector projects. And at the moment, I'm an independent contractor, but working currently with Runna and have been since February of this year. If anyone particularly wants to connect with me, feel free to grab one of the QR codes either for LinkedIn or to email me directly. That's fine. We can pop those up again later if we need to. But to give a bit of a background, Runna as a company has been going for about 4.5 years now. Currently the #1 running training app in the world. So woo, go us. And originally founded back in March of 2021. Originally, it wasn't actually an application specifically. You would basically contact Ben and Dom, the founders, and they would send you a personalized, customized running training plan via PDF. They released the first version of the app in December of 2021, and it's since then evolved and added more and more features to become the running training app that everybody loves and knows today. When I first started at Runna, this is a bit of a summary of the data landscape that they had. So there was around 30 terabytes worth of data in cloud storage, specifically in S3, because we're an AWS-based company. We have our largest data set was around 50 million rows, which is our activity data set. So within the Runna app, whenever you do what we call an activity, so that might be you might go for a run, you might do some Pilates, you might do some strength workouts, whatever it is, all those get logged as activities. We had about 50 million of those when we started. And we use DynamoDB as our operational database. So most of the Runna app is powered by DynamoDB. And when I started, there was about 75 different Dynamo tables powering various parts of the application and a whole bunch of different third-party data sources, sort of like, providing our app tracking and like marketing stuff. So the whole bunch of different stuff, loads of different data sources that we have everywhere. Now, the challenge with all of that is that it's very, very difficult to query. When you've got data in lots and lots of different places, connecting it together and trying to drive insights from that is actually really quite difficult. And so that kind of leads into the second problem that we're having, is that when it's difficult to join this data together, it's hard to drive any kind of real business insights. So answering basic business questions like how many people did a tempo run last week, or how many people have signed up for this specific race, was actually shockingly difficult to answer. Sorry. And so that's kind of like the main driving force behind Runna's desire to build out a data warehousing solution and to kind of start to be able to answer those questions in a more detailed way. Now, when I started, Runna were very much at stage 1. They've got data in lots and lots of different places. It's not very organized, and it's very, very hard to build anything meaningful. And the goal was to basically get them as far along the Lego diagram as possible, trying to get them to stages 5 and 6, where it's easy to kind of articulate and explain what's going on within your data, and then start to build actionable insights out of that. Oh, we'll skip slightly. It's preview. I mean, you'll never guess who wins. So yeah, we started out by analyzing on paper a whole bunch of different data warehousing solutions. So the 5 logos that you can see on screen are the ones that we started with. And we were basically looking at what features do they have, what's their pricing model like, what's their customer support like, et cetera, et cetera. And we very, very quickly narrowed it down to just the 2, so Snowflake and Databricks. They're the ones we took through to a proof of concept stage. Now, for our proof of concept stage, basically what we did is we identified some key use cases that we had. So stuff like loading data into the platform, doing some transformations, building out dashboards and kind of analytics based on that information, and using kind of Jupyter notebooks, Python notebooks to kind of do data analysis and transformations. And just to kind of like, I guess more the experiential side of things. So when you're working on these types of platforms, like how easy or difficult it is to use drastically kind of impacts how much you want to work with that solution. So a big part of it for us was how easy is it to use? How useful is it? Is it intuitive? Is it difficult? Do you have to get in there, like muck around with stuff to make things work? And because of who's sponsoring this talk, Snowflake, you can have a guess who wins. no prizes there. So yeah, we ended up just kind of choosing Snowflake just based on, cost performance reasons. The developer experience for us was significantly better. And one of the key factors for us as well was having Snowflake be a primarily SQL-based interface massively lowers the barrier to entry for a lot of engineers. They don't have to know Spark. They don't have to kind of learn some of these more complicated languages. Most engineers can learn or already know SQL relatively easily. The other benefit for us was that because we're an AWS-based platform, Snowflake and AWS very, very tightly integrated. So we've got a whole bunch of different ways that helps us out. So we use storage integrations, which is basically an integration between Snowflake and your cloud storage buckets, so S3, that allows us to directly access data that's in our cloud storage buckets, load it into Snowflake, and it's all kind of seamless. You don't have to manage extra special permissions and stuff. And because the Snowflake is based in a whole bunch of different regions, it made it very, very easy to meet our regulatory compliance needs. So for stuff like GDPR, where you have to keep data in certain locations, again, we could keep everything in the same location, so there wasn't any problems there. So we've decided on a solution. Now, what's the actual task? We've got a whole bunch of different data in different places. So we've got data from DynamoDB, S3, and just 5 of the many other logos of places where we keep data, from advertising or for revenue tracking or, app installation tracking, etc. We need to gather all of that and deliver it into Snowflake. Now, that in itself is difficult, as we've already established. The data is coming from all over the place. There's loads of different ways you can grab that data. So at a very, very high level, we decided to implement a pattern. The pattern is get data, put it into an S3 bucket, and then use EventBridge to trigger off an event that fires into a Snowflake instance, triggers the Snowpipe, and loads the data into a raw landing table, from which we can start to do transformations. We can start to look into it. We can explore it. A whole bunch of useful stuff we can do. And the reason we went with ELT, so extract, load, transform, is that because we're doing this kind of from scratch, we don't know a lot of what the target's going to look like. So for us, having the ability to transform inside of Snowflake and not have to worry about doing the transformation in flight just made things easier. We could iterate much faster. DynamoDB is our biggest use case. So we had 75, as I mentioned, DynamoDB tables. So a more specific implementation of this pattern was we would have a DynamoDB table. We would connect to the DynamoDB change stream with a Lambda function. That Lambda function takes the DynamoDB change that's happened, transforms it ever so slightly to put it into a nice consistent format. And then we write it to Kinesis Data Firehose, which basically streams it in batches into S3. And then the rest of the pattern is basically the same, where it triggers the event, loads into a Snowpipe, and lands in the landing table. And to give you a bit of context about how we set up our S3 buckets, this is an example kind of object name. So S3 bucket, then the DynamoDB table name will be the very first portion of the prefix, and then year, month, day for the date of ingestion. So it's very, very easy for us to identify where the data has come from, when it was ingested, a whole bunch of useful stuff. It makes it nice and easy to process. Just going to take a quick drink of water. So once it's in Snowflake, what do we do with it? So it lands in that leftmost column in the layer that we call raw. And because with a lot of these data sources, your data isn't static. It's constantly changing. Users are updating their settings. People are setting new personal bests. There's a whole bunch of changes that are constantly happening. So once it's landed, we need to figure out what the latest version of any given object is. So we kind of abstracted that into a latest layer. So for every single object that lands, we know what the primary keys are, because that's part of the definition of the object that we kind of load in. And we use a basic group by and some ordering to determine what the latest version of any single record is. And that's just stored in the latest column. So any kind of downstream models can always refer back to that if they need to know the current state of the object. They don't need to be kind of worried about historical context of each object. The next stage that we implement is what we call a common layer, which is basically, it's kind of very similar to a semantic layer, where we are defining what the standardized versions of every object is. So for an activity, this is what it should be. That would exist in the common layer. For a user, what does a user look like? That kind of standard definition exists in the common layer, and that's for the entire business to be able to draw upon and use and build upon in their models. And then to the right of that, we have effectively our data marts, where our individual consumers, so our growth team or our train team or our app team, they can kind of take that data that's available to them in the common layer, add what additional transformations they need, add additional data, anything that's kind of bespoke to them. And they load that, they can build it in their own space, they're not fighting over namespaces, etc. And they have an entire autonomy and control over everything that's in that area, which is great. We implemented this with dynamic tables. So dynamic tables for us, probably one of my favorite features actually ever implemented in Snowflake, because I don't know if anyone's used Snowflake historically, but if you wanted to kind of do a constantly changing set of tables, historically you would have to do stuff like implementing tasks, using change data capture, and materializing the tables yourself, or using stuff like materialized views. But dynamic tables is basically that, but automatic for you. So you just define a SQL query, and Snowflake magically does it in the background. It's fantastic. And just to give you an example, here is one of our dynamic tables that we kind of set up. So all the way over there on the left, you can see we've got our raw layer where our activities are loaded. And then we've got our latest layer in the middle. You see there it says target lag 1 hour. That's because one of the downstream consumers also has a target lag of 1 hour, but another one doesn't need to be updated that frequently. So target lag of 1 day, but you can see how they're all connected. You get some nice data lineage there, and you see how it all flows through, and we're able to build out multiple models from one kind of source data set. One of the complications that can arise when doing stuff with dynamic tables and just like kind of Snowflake warehouses in general is you might have another user, let's say somebody in the analyst team who's doing a large query. That can sometimes, if you're not careful, have a negative impact on the queries that you yourself are running, or that's just kind of generally running in the background. So we decided to implement workload isolation. Workload isolation basically guarantees compute for specific tasks. So anything that was in the latest and the common layer, they're effectively protected in a little bubble. They get their own dedicated compute resources, and then other people, other teams, they have their own dedicated warehouses that allows us to separate. That means they can't fight over compute, they can't interrupt each other. We have a lot of fine-grained access control as a result of it, and it's just easier to attribute cost as well, because we can say, okay, well, this layer has cost this amount, but also we can see that this other consumer has spent $100 on this particular model in this month. So it makes it very, very easy for us to do kind of all that cost attribution. And it's also quite nice for irregular and bursty workloads as well, because most of the time our warehouses are just like automatically shutting down after a minute of inactivity. Sorry. So that kind of draws us to where we are right now at our fairly nice, clean solution. So if you remember back to the start of the talk, I talked about how it was very, very difficult for us to compare data from different data sources and to kind of answer some of these larger scale questions. So now that all of our data is loaded into Snowflake, and we can just kind of use the power of Snowflake to query between those tables and to kind of perform these ridiculously large aggregates very, very quickly, it just makes answering all those questions significantly easier. And I've got a really good example for you. Very recently, probably about 4 or 5 months ago, one of the ML engineers came up to us and said, hey, we want to build a training data set for a particular use case, a feature that they were working on at the time. And we need to collect user data, we need to collect activity data, we need to collect, what plans people are on, what races people are signed up for. So a whole bunch of different data sets. And they'd worked out that they could write it all in a Python script and run it kind of locally and, get a bunch of data from DynamoDB to do it. But it was going to take them about a week and a half to write the script and probably about 3 days to run it. So what we did was we loaded all the data that it needed into Snowflake. We did some basic transformations for them. And then we ran the query, basically trying to collect together all the information that they needed. The query ran in about 10 minutes, and it took about 20 minutes to write, and the data loaded in about an hour. So in an hour and a half, we'd save them 2 weeks worth of effort. So this is a kind of impact that, well-structured and organized data, when it's in a tool like Snowflake, can have. It makes it just so much easier to do these like kind of large-scale aggregates. And I guess I gave a couple of other examples, like, how many people did a tempo run this week at the start of the talk. That now takes about 3 seconds to answer rather than several hours. And again, all these things are just so much easier. And we've got a whole bunch of other benefits here. So scale is better. Obviously, as we've been doing this, we've been documenting things properly. We've got a much better user experience. It's just a nice way of implementing and accessing all this data. In terms of our future plans, obviously, everyone's big on AI. We have a whole bunch of teams that are leveraging machine learning and AI already. And so we are intending to use Snowflake as much as possible for building out the future of our AI projects. So at the moment, that's probably looking like building out the training data sets, because like I said, historically, the teams that have been collecting those, it takes a while and it's quite difficult for them. But we're hoping to get that to a place where they can define a data set they need and it can be exported in, a matter of hours rather than days or weeks. And we're also comparing the actual training of those models, seeing it, comparing that with Snowflake ML to some of our existing solutions. And I know a couple members of the team have also been messing around with Copilot and Cortex too. So this is kind of drawing toward the end. At Runna, we are always looking for, talented and passionate people. So if you are interested in a job at Runna, feel free to go to runna.com/careers, scan the QR code. We've got a whole bunch of vacancies open at the moment. And if there isn't one that suits you right now, there's an option called register your interest. So if a role comes up in the future that you think would suit you, just feel free to register your interest and we'll reach out at the time. We've also got some merch if anybody wants. So we've got some stickers, we've got some wristbands, and we've got a limited number of hats going to be peddled by my colleagues by the door. Emily and Jack, do you want to give a quick wave? So if you want some merch, just go and find them. They're right by the door to be able to do that for you and give you some stuff. And right now, we're at the end. So if anyone has any specific questions, I'll be happy to answer them for you. We've got a microphone coming down, so the question over here. It's probably the furthest one you could have found. Sorry.
You all right? That's how it all worked out in the end.
Yeah.
What were kind of the main challenges or hurdles that you had throughout some of that engineering process?
So it sounds a little bit cliche to say, but it all went quite smoothly, if I'm honest. Like there weren't any kind of major challenges. So we did a lot of discovery to obviously go and identify all the different data sets. We still have a whole bunch of those outstanding. So we're not finished. It's a work in progress, but we have a lot of the kind of core, the major ones. I think if any of you worked in data for a decent amount of time, you might have 100 different data sets, but maybe you use 20 of them 80% of the time. So we've kind of ingested the majority of them. I think one of the bigger challenges we had to, obviously we built some bespoke functionality to onboard DynamoDB. So there are other options available. So recently Snowflake has released a product called OpenFlow. It wasn't around when we were doing this, but we got a chance to look at the preview and we decided it wasn't quite the right fit for what we were trying to do. So we ended up just kind of rolling our own in Lambda functions to it connecting to the change streams. And also because we needed the historical data for items that aren't changing, we also implemented a solution that would take a DynamoDB export, transform it, and also load it into Snowflake in the same fashion. I just didn't cover it in the presentation because it's basically the same thing. That took about a week and a half, 2 weeks to make. But other than that, it's been relatively smooth sailing, to be completely honest. I feel quite lucky. Normally something goes wrong. Yep. Another question is here.
What was your approach when you build a new data model? Right? Because you are not using the existing model. You have put a different data marks. I've seen that schema. So how you have managed that?
Okay, yeah. So what I'll do is I think I'll give you like a little bit of a walkthrough of our process. So because of the way that we built the solution, so we have basically we homogenized a lot of the inputs, which meant we could build reusable tools. So for example, if we want to ingest a new DynamoDB data source, we have to make a configuration change. We add an item to a list, it loads it into the database, it builds out the tables for it, it assigns all the compute resources, and then it's all available in the latest schema, ready to be modeled. In terms of actually doing the modeling, we'll have a member of the team, either an analyst or an engineer, go and analyze the data. They'll pick through it. They'll figure out what's important. Maybe we'll go and talk to the team that manages that data source. So around Runna, we've got different teams managing different bits. So they'll manage their own data sources. We might go and talk to them and say, oh, what does this bit mean? How does this bit work? And what fields, most importantly, are important to you and to the wider business. And we'll take those and we'll translate it into a data model that we build out in Terraform, and then we deploy into Snowflake with CI/CD. That process, depending on how complicated the model is, anywhere between half an hour and a couple of days, but it just depends on the complexity. For some of the other data sources, like third-party data sources, depending on the structure, like sometimes they come in as CSV, sometimes they come in as JSON. It kind of depends, but it's basically the same process. Any other questions around? Oh, one at the back, I think.
Thank you very much. Speaking to the core of the product, of course, the initial running plans were delivered by PDF from the founders of the business.
Yep.
Has your maturity in terms of data, in terms of pipelines, given more strength to that initial product offering, or do you feel like it's mostly bolstered the scaffolding around the whole app?
So the way I see data at Runna is it's very much a support service at this point. But we are starting to integrate the data that we have within Snowflake to kind of feed back into the wider business. So we've got some new features on the horizon and some that have been released quite recently that we are actively taking data out of Snowflake, exporting it back into the application, and then using it to power that feature to make it more effective. So an example might be, let's say we need a summary of some data, like counts of activities or total distance ran, etc. over a time period. To calculate that on a per user basis using something like Lambda is very possible, but it takes time, and it's not the most efficient way of doing it. So what we do is we have a batch job in Snowflake that fires every hour, that generates that data, exports it to S3, and then we have another tool that loads it into a DynamoDB table ready for super fast and scalable access by the application. And then that way we avoid large scale, huge amounts of concurrent connections to Snowflake, but also we're able to generate en masse the data that's required on a cadence that kind of suits the needs of the application. Excellent. In that case, one more is there on the left?
It's really interesting to see kind of a big architecture over dynamic tables. I'd be interested to know kind of what you've got in terms of checks and balances for maybe data quality and observability.
Mm-hmm. So that's something that is on the roadmap, but considering this project started only about 6 months ago, we're still relatively early in that journey. We're looking at different tools. So, for example, a tool that I've used historically for performing stuff like data quality checks would be something like Great Expectations. But we're going to very much the same as we did when looking at data warehousing solutions and what we did when we were looking at BI reporting solutions. We're going to go to the market, we're going to evaluate things, and we're just going to figure it out. But I don't have a concrete answer about that right now. Sorry about that. All right, I think that's everybody. Thank you very much.